Assalamualaikum warahmatullahi wabarakatuh. My name is AINSSA SAIDI and I am from groups A7. Today, my group members and I are going to present about our research on the development of new stretchable conductive ink. First, I'm going to summarize our project. The project's goal is to discover a new SAI material formula that can create a highly conductive, stretchable and reliable material for flexible PCB boards under different stresses and temperature. This is a result of the limits of the current materials, which are impossible to exist along with flexible PCB boards and are employed on non-flexible PCB boards. We have decided on polydimethyl siloxane, PDMS, as the matrix material, graphene as metallic fillers, and thermoplastic polyurethane, TPU, as the substrate material. For the problem statement, electronics that are stretchable can be compressed, twisted, and attached to very complex shapes. The creation of a printable conductor or electrode is the hardest element of producing materials for flexible printed electronics. Additionally, when chemical sensors are used, their use can lead to poor deformation of wearable technology, including power supplies and sensors. Each material has a unique degree of flexibility and connection, which we need to understand. Therefore, the material that we want to use should have a high degree of connection and flexibility. For the background study, a PCB is a solid structure that houses electrical circuitry made out of embedded metal surface known as trusses and larger metal section known as planes. As they are now made, PCB are physically weak and readily break under intense pressure. In order to get around this issue, various conductor fillers have been used in printed electronic technology as a replacement for PCB technology and to increase the flexibility of the circuit. Both subtractive and additive conductor methods require a complex manufacturing infrastructure for PCB. Nowadays, the essential new electronic qualities include cheap manufacturing costs, long-term durability, environmentally friendly production methods, recyclable material, reduced energy consumption, increased efficiency, and electronic integration with other structure. The transition from hard, uncomfortable electrodes to the more inexpensive and disposable sensor pads of today has been sped up by the introduction of stretchable conductive ink. That's all from me. Next, my group member is going to present about the nano composite.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMMAD bin SAIMI. What is nanocomposites? Nanocomposites is a method to which nanoparticles have been added to improve a particular property of the material. A substance in which one of the faces has 1, 2 or 3 dimensions that are less than 100 nm and the structures possess nanoscale repeat intervals between the distinct faces that make up the material. It naturally occurs and can be found, for instance, in the structure of bone and abalone shells. The nanocomposite's mechanical, electrical, thermal, optical, electrochemical, and catalytic properties will be significantly different from those of the component materials. In comparison to their microcomposite counterparts, practically all types and classes of nanocomposite materials show new and better properties according to experimental work. These are some example applications of nanocomposites in industry. In aircraft, with its high glaciation temperature, excellent physical and mechanical performance, and low viscosity, epoxy is a versatile material. The aircraft industry uses high-performance composites to produce fuselage sinks. It also has excellent anti-corrosion qualities and can be used as a topcoat on airplanes. For structural, when it comes to mechanical qualities, polymeric nanocomposites really shines and it also has excellent electrical conductivity. Therefore, it is the superior option for structural users. For the materials development, this is the formulation of PDMS. PDMS is a polymeric organosilicon chemical that belongs to the class of silicones and siloxanes. The silicon-based organic polymer PDMS is made of repeating SiO-CH3 2 units. At room temperature, it is in the rubber state since its glass transition temperature is less than 120 Celsius. Due to its chemical inertness, moldability, oxygen permeability, and liquid impermeability, this elastomer has been demonstrated to be useful for building microfluidic devices and biosensors. Its pliability, biocompatibility, and mechanical adaptability make it a desirable choice for stretchable device. Formulation of graphene. Graphene consists of a single carbon atom layer. Graphene's oxidation leads to the formation of GO. Through a number of reduction processes, GO is reduced by reducing agents to become RGO. To increase the solubility of graphene, several groups have been bonded to its carbon backbone by chemical modification, covalent functionalization, and non-covalent functionalization. Graphene are valuable due to their high conductivity, thermostability, and outstanding mechanical strength.
Assalamualaikum, my name is Ahmad bin ALIAS. I will continue about materials developments. So this is the formulation of thermoplastic polyurethanes, TPU. So many biomedical applications choose the thermoplastic polyurethane due to its relative ease of manufacturing into devices, flexibility, biocompatibility, biostability, and electrical insulating qualities. So TPU comprises flexible coil and inflexible hard segments that can be melted without the urethane linkages degrading. These are mostly linear chains with molecular weights in the range of 15,000 to 40,000 and a glass transition temperature below 0 degrees C. Due to the variety of possible combinations of flexible and stiff segments, it is possible to develop materials with a range of qualities, from soft and flexible elastomers to rigid thermoplastic with a high modulus. So that's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is MUHAMMAD bin JAMALUDIN and I will explain about processing technique of stretchable conductive ink. Basically, there are three types of technique involved in producing this stretchable conductive ink, which is mixing, printing, and curing. Okay, first, mixing. The layer of conductive filler network is typically deposited using solution processing technique, followed by a process that involves the evaporation of the solvent. Before the conductive filler can be processed using the solution, it must first be scattered equally throughout the solution to eliminate the possibility of an uneven distribution of conductivity over the deposited region. Okay, next, printing process. It is a low-cost and simple procedure. With this printing process, a pattern is imprinted onto a fine mesh, screened together with section of impermeable coating. A scrap is then used to drive the ink throughout the mesh onto the printing square by moving over the mesh. Lastly is curing process. It is a photochemical technique that uses intense ultraviolet light to immediately cure or dry inks, coating, and adhesives. The photoinitiator performs a chemical process when exposed to UV light that enables it to link independent oligomers and monomers into a more complicated chain. High conductivity can be achieved by heating to a higher temperature and burning away any organic contaminant and solvent. That's all from me. Thank you.
So now, my name is NURUL RAHIM and I will present for part tensile test on TPU for our presentation today. Shimadzu AGSX Universal Testing Machine was used to perform tensile tests on various blend composition in accordance with ASTM D638 Type 5. From the molded sample, dumbbell-shaped samples of 3 mm thickness were cut out, and they were evaluated at a crosshead speed of 10 mm per minute. Each composition had a minimum of 5 samples examined. And then, using an ultrasonic bath sonicator, ethanol and epoxy were combined for 20 minutes at room temperature. After that, the solution was mixed with functionalized graphene and the mixture was once more sonicated for 30 minutes in an ultrasonic bath sonicator. The subsequent mixing of functionalized graphene and epoxy as well as the evaporation of ethanol were done using a hot plate magnetic stirrer. The solution's temperature shouldn't increase over 70 Celsius. To remove air bubbles, the entire compound was degassed in the vacuum chamber for 10 to 15 minutes. It was then poured into a specially prepared mold to create the specimens, and then leave the mold to create the specimens leave the mold at room temperature for 24 hours so that it can cure. The specimens were then post-cured in a vacuum oven for an additional 4 hours at 100 Celsius.
So here we can see about the tensile test. We can have the sheet or bulk resistivity, which we can measure by the electrical resistance formula, which is V is equal to IA, where V is voltage, the parameter is volt, I is current, parameter is ampere, and R is resistance, which parameter is ohm. But every material has its own resistance, which is called resistivity. So we can measure this by Rs is equal to G E multiplied by V over I, where we can assume Z is to be 4.53. So here we can see that for recent advance in stretchable ink technology, for electrical devices, bending, rolling, folding, and stretching, among other features that in conventional electronics cannot satisfy. So, which was not emerged in ensuing like decades. Currently, as high-performance scalable electronic device directly fabricated onto flexible substance, which has done for the materials and fabrication techniques. As elastomic substance with potent molecular interaction are used, this interest has expanded to include not only flexibility but also features like stretchability and healing ability by our modern and electronic technique and fabrications. So here we have faced some problems which we need to cover on, like graphenes in a tendency to agitate, so it is difficult to make particularly viscous and concentrated graphene dispersion. But on the other hand, we can see from 2001 the government is funding to NNI $22 billion, and which is still going on for funding. So this statement supports the demonstrate of nanotechnology's potential. So in future, we can say that we have more opportunity than before. Thank you very much. Thank you everyone.